Hello, my name is Marcin Stolarski. I'm working in the Space Research Center Polish Academy of Science, and I would like to present my estimation of the PWSat satellite orbit based on the Doppler effects. And today I say a few information about the PWSat. I show you my test equipment, show the base question which of the space object is the PWSat. I show you the measurement data, analyze this data and results. PWSat is the satellite designed by the Warsaw Institute of Technology, and is the CubeSat size small satellite designed by the students. And for the communicate, it used the UHF and VHF radio amateur bands. For the uplink, we use the UHF IFSK modulation 1200 kilobits per second, and for downlink we use a VHF BPSK 1200 bits per second, and we can use the Morse code modulation too, or we can set the satellite in the voice repeater. It means that it receives the FM modulation and send this modulation like the DSB signal. If you look on the slide, you see the schematic diagram of the communication module. This communication module is from the ISIS company, and here you have the two stage of the frequency conversion receiver, and the received FM signal can be demodulated by the AFSK demodulation chip and sent into the microcontroller, or can be sent directly to the BPSK modulator and transmitting in the repeater mode. If we see the transmitter, there's the microcontroller which generate the BPSK signal using the software-defined radio technology, and after the digital to analog converter, this signal is mixed, upconvert, amplify, and sent to antennas. PWSat is operated by the ground station designed for the bright operation. We have the ground station built in the Nicholas Copernicus Astronomical Center in the Warsaw, close to my work. And this system has two installations. One on the mast one is designed directly for the bright satellite operation, and on the second mast we have the system for the radio amateur satellites. We use it for the learning the radio amateur operators in the ground station, or for example for the today we use this for the PWSat, and maybe we will use in the future Polish missions. And the maximal RF output of this ground station is about 1.2 kilowatts. And on this picture you can see this mast is used for the PWSat. And this presentation based on my home ground station. It is much smaller than our ground station for the bright. I have only two antennas. One is the VHF, one is UHF, and on VHF I can receive signal with 11 dBi gain of this antenna, and my maximal RF output is 50 watts, so it's much smaller, but for this experience it's absolutely enough. And the main problem is that after the Vega 1 launch, this rocket eject to the space 7 CubeSats, and after ejection the NORAD organization only sign any satellite by the number, and the owner of the satellite should decide which of the number is his own satellite. If you look on this picture, you'll see the simulation of the position of the satellites ejected during the WILGA launch, and this is the situation after 1 month. So still satellites are very close, and it's really hard to design using only the time observation of the raising and setting of the satellite. So I decided to use the Doppler effect to detect which of the satellite of this cloud are our Polish satellite. Base information, what we should know is the frequency of the satellite, but there's the little problem. PWSat, we have only the documentation of the company who designed and built this module, but we haven't any own measurement, for example spectrogram or something like that. We have only one information of this satellite. This is the photo when you see the student who operate with this satellite using the radio amateur transceiver, and you see the frequency of the transceiver is 145 megahertz and 904 kilohertz. So this is probably the frequency of the satellite on the Earth. But for the high quality measurement, we need to build some of the better equipment. This is equipment where I use in my home. This is my antenna system, and I use PhoneCube dongle. This is the software defined radio receiver, which can operate from 50 Hz to 2 GHz. And you can measure, you can present signal by the audio or by the spectrogram or what you would like. In real, this is software. If you use the software-defined radio technology, you can do with the signal anything what you would like. But the problem is that this receiver haven't at the front end high quality filters. So I decided to use my own high quality satellite transceiver, Yaesu FT847, and get signal from the if output, but this if output is little too low for this receiver, so I add second stage using my second all band receiver, which will up convert this signal 45 MHz to 70 MHz, and if output of this receiver I connect directly to my PhoneCube dongle. Of course, if we use several stages of the frequency conversion and you have inside several generators, it's very hard to decide what of the frequency receiving from here it's received here. So I add to this equipment the high quality compensated signal generator, which generated a carrier close to the satellite frequency, and all of the measurement here are comparing to this signal from this generator. And on this picture you see the received from the space one PWSat packets. You see that here we have about 2 seconds of receiving signal. Here we have the bandwidth. It's the bandwidth of the signal is about 2 kilohertz. And you see that this is the start of the packets. The satellite, the transmitter when start, that has a little drift here, and this drift is I call this starting transmitter, and there's the drift of the starting generator in the satellite. And then we have the small drift, which is drift of the Doppler, based on the Doppler effect. And this packet is begin from the header. It's the this header is the BPSK carrier. Then we have the small part with the data of the telemetry, and this packet ends using this BPSK carrier. So if we observe this middle of the carrier, we can precisely measure the frequency of this satellite. Next diagram show measurement frequency of received 3T PWSAT packets. I need few days for and about 8 communication window for receive all this data, because satellite doesn't transmit all time. It transmits packet from time to time, and typically it transmits data by 2 minutes, and after them there's the 16 minutes of the quiet of the satellite. When we look on the data from the telemetry, we are thinking that satellite transmit data until the battery is fully empty, and after them 16 minutes satellite needs to recharge battery to the minimal value of the voltage when the satellite start again, and start transmitting by the 10 minutes until the battery is not empty again. You see that the frequency is from about 145 megahertz and 903 kilohertz to 145 megahertz and 909 kilohertz. So the Doppler effect is about 6 kilohertz. And on the next diagram you see combined packets to the communication windows. So you see the time when the satellite transmits, the time when satellites are quiet, and maybe the most interesting is here when the satellite is rising up from the horizon and transmitting data. After then we have the 16 minutes of the quiet, and then satellite start again and transmit until the satellite set under the horizon. So when we get data from this diagram, where the average frequency we have here, the maximal and minimal frequency it's here and here. If you average this two frequency, we can middle frequency it's here, and when you combine this frequency to this frequency, so compare, I decide that for the simulation I use 145 megahertz and 96 kilohertz. So this is compared to this frequency which you see on the receiver, because this receiver is the USB mode, so there is about 2.5 kilohertz movement. Okay, and on this picture you see the number of the packets received, this windows which I use for communication, the data and time or when we receive any packets, and measurement frequency. And here we have the calculation for expected frequency based on Doppler effects and Kepler elements of any of the object from C to J, C, D, E, F, G, H, J. Okay, and on this red color I paint this object which are out of the range of the ground station. It means that this object was under the horizon, and green color show the frequency which are the closest to measured frequency. And you'll see that most of the green color has the object G. On the next page you see in this place you see calculated delta between expected frequency and the measurement frequency, and still the object G has the smallest value here, and this value and when we average all of this measurement value of the delta, there is about 88 Hertz, so they're very, very close. But the next object is only 3 times bigger value, and the other objects are very, very much bigger. So their objects are very close. And when you observe here, there is the object G and F, so the two objects are very close in the clouds. But I think that this value is enough to decide that object G has the correct value. Okay, and now on this picture you can see situation after next 2 months, and object G is here, object F is here. It's now it has its own name of the satellite, and you see the distance between them is much bigger, and we know that we still use object G for communicate with the PWSat, so we know that PWSat is the G. So my calculation was correct, and correct to show which object are expected is the PWSat. And when you see analysis of the rest of the object, 3 of them in the green color has their own name, official name. Object J has quite strange situation, because I found the website that 2 satellites say that they are the object J. Nobody thinking that they are the object H. And I expect the object D is probably Robusta CubeSat, but this satellite has the problem in the power supply and is disabled, so probably when all of other objects will have owners, then object D will be named Robusta. So summarize, I show you some of the background information about the PWSat. I showed you the problems for estimate object of the position, which of the clouds is the PWSat. I showed my tools which I use and results which I calculate using these tools. And at the end, after 2 months, we have the confirmation that my results are correct. So thank you very much for your attention. If you have a question, you can send me email or you can call by the phone. And sorry for my absence today. Thank you and have a nice day.